Hello, my name is Keith Johnson, and welcome to my presentation on Kamiak Butte. Throughout the presentation, we will get a deeper understanding on Kamiak Butte's ecology. This report is from my SOE 300 class at Washington State University. I hope you enjoy. Listed below are the main discussion points that we will be covering in the presentation. First being the history of Kamiak Butte's geologic foundations. It's quite a long one, but is crucial to understand how Kamiak Butte came to be. The second is the climate of the butte, followed by the biome. Next, we went on a virtual field trip for the class and took some field data on the different types of trees on the north side versus the south side. Lastly, I will go a little more into depth on Kamiak Butte's different types of vegetation. To go into the geologic foundations of Kamiak Butte, we first must go about 200 million years into the past when the supercontinent Pangaea existed and began spreading apart due to seafloor spreading. Seafloor spreading occurs at divergent plate boundaries. As tectonic plates slowly move away from each other, the heat from the mantle's convection currents makes the crust more plastic and less dense. The less dense material rises, often forming a mountain or elevated area of the seafloor. Eventually, the crust cracks, moving the landforms apart. In 1912, Alfred Wegener proposed a theory that the continental landmasses were drifting across the Earth. Many scientists of his time laughed and scoffed at his idea, but it wasn't until 1960 that his idea was actually proven to not be a theory anymore, but a fact. Now that we have a better understanding of how the continents spread apart, we can focus on how Kamiak Butte began to take shape. This all started when the Juan de Fuca plate subducted underneath the North American plate. Not only did this create the famous Ring of Fire, but when it released magma, it created mountains of quartzite such as Kamiak Butte. Basalt is a common rock all over the Palouse, and it was caused from lava flows from the Yellowstone hotspot around 17 million years ago. As the lava flowed over eastern Washington, it created the popular Columbia River flood basalts and covered most of the quartzite mountains such as Kamiak Butte in layers of basalt. This is why under the low soils of the Palouse, you'll find basalt. Next up, we have the most recent geographic change called the Missoula floods, which occurred around 13 to 15,000 years ago. Glaciers up in North America began to melt, which caused a large amount of water to flood into Lake Missoula, located in western Montana. Soon, the water pressure in the lake grew to be so intense that the water burst through the ice dam, causing cataclysmic flooding all over eastern Washington, including the Palouse. However, this ended up benefiting eastern Washington in the long run. When the water from the Missoula floods drained out, it left behind mountains of organic matter and silt. The marine polar air systems then dispersed the silt all over the Palouse. This created the low soils found all over the Palouse. The low soils combined with the basalt is what makes the Palouse such a great farmland for wheat and other crops. Kamiak Butte climate has hot, dry summers followed by cold and snowy winters. The climate is influenced by marine modified continental macroclimate and the dry continental macroclimate. Below is two graphs comparing the climate in Kamiak Butte in 1895 to 2019. Another big part of Kamiak Butte's climate is the rain shadow. The way it works is marine polar air blows cold, moist air and clouds to the Olympics, Rockies, and Cascades. Then, when the clouds rise over the Cascade Mountains, the clouds will cool and condense, losing a lot of their moisture. From these clouds is the way that Kamiak Butte and the Palouse gets its rain, but when compared to the west side, it's nothing. Kamiak Butte is located in a western interior shrublands and woodlands biome. This particular biome makes it hard for most tree species to grow, which you'll see in the next few slides. This biome spreads all the way from British Columbia to New Mexico. The next two slides will be dedicated to our virtual field trip of Kamiak Butte. The main purpose was to compare the vegetation of the north side and the south side of the butte. We compared the species and number of trees on each site, distance from plot center, diameter at breast height, and finally the height. Below, you can also see the exact location of where we were placed for both the north and south side. Off first glance, it is easy to tell that the north side of Kamiak Butte has a lot more vegetation than the south. This is due to the topography, which makes it a cooler and moist side with not as much direct sunlight. It also has a wider variety of trees and other plant life. This section of the butte would be considered a forest land, being primarily dominated by Douglas fir trees. The trees on the north side are also much taller than the south. This slide is on the south side. Based on just the picture, it is easy to tell that this slide has a lot less vegetation than the north. This would be considered a shrublands biome due to the height of the trees. It is also primarily dominated by ponderosa pine trees, which due to the conditions are much shorter than the trees on the north. You can also tell how dry this side of the biome is where compared to the north due to the constant amount of sunlight exposure. This next section, we were given the opportunity to choose a topic that we wanted to learn a little more about in Kamiak Butte. I chose to dive a bit deeper into the vegetation, talking about the types of ferns, wildflowers, and trees. The 5 ferns I looked at were the bracken fern, polypody fern, fragile fern, lacelip fern, and the western sword fern. They primarily grow on the north side due to the topography of the area. Also, something to keep in mind, the odd names that follow the actual fern, wildflower, and tree names are their scientific names. The 5 different types of wildflowers I found to grow on the butte were glacier lily, yellow bells, taper tip onion, sagebrush mariposa, and false Solomon seal. Just like the ferns, these wildflowers also grow on the north side rather than the south. Kamiak Butte has 3 main different types of tree species: the Douglas fir, which is mostly on the north side, ponderosa pine, which primarily grows on the south side, and the western larch, which grows amongst the Douglas fir on the north side. Thank you for tuning in into my report on Kamiak Butte and its ecology. I hope you're able to learn something new.